2sum is the number one most asked interview question. Most engineers ship the O of n squared answer. There is a way to do it in O of n, but before we build that, we need to feel why n squared hurts. Today, the brute force. 2 parts to this problem. Part 1, the brute force, nested loops. Part 2, one-pass hashmap. We are in part 1. The problem: given an array of integers and a target number, return the indices of the two numbers that add up to the target. Exactly one solution is guaranteed. You may not use the same element twice. 3 examples. 1. Input 2, 7, 11, 15, target 9. Output 0, 1. Because nums 0 plus nums 1 equals 9. 2. Input 3, 2, 4, target 6. Output 1, 2. 3. Input 3, 3, target 6. Output 0, 1. Notice: same value, different indices. Both are valid as long as the indices are distinct. Constraints worth knowing: the array has at most 10,000 elements. Values range from -1 billion to +1 billion. Exactly one valid answer exists. That 10,000 cap is small, and it is small for a reason. The brute force does n squared work. At 10,000, that is 100 million operations. Just barely fast enough. Many other problems set n to 10 to the 5th or higher, and the brute force times out. The natural first thought: if I need two numbers that sum to a target, I check every pair. Every possible pair. For each element, I try every other element to its right. If their sum hits the target, return their indices. The flow: start with I equals 0. Inner loop: j equals I plus 1. Check: does nums I plus nums j equal target? Yes. Return I comma j. No, increment j. When j runs out, increment I and reset j. That is all the brute force is. Trace on example 1. Array 2, 7, 11, 15. Target 9. Outer I equals 0, value 2. Inner j starts at 1. 2 plus 7 equals 9, match. Return 0, 1. Done in one iteration of the outer loop. Lucky on this example. The answer was the first pair we checked. The code in JavaScript. 8 lines. Function takes nums and target. Outer loop I from 0 to length. Inner loop j from I plus 1 to length. The j equals I plus 1 matters. We never compare an element with itself, and we never check the same pair twice. Inside, if nums I plus nums j equals target, return I, j. False through the loops with no return, which the problem guarantees never happens. The numbers: time complexity, O of n squared. Space complexity, O of 1, we use no extra storage. For n equals 10,000, that is roughly 50 million pair comparisons in the worst case. That barely fits in a 1-second time limit. Acceptable, but only just. 3 traps that cost engineers points. 1. The inner loop must start at I plus 1. Start at 0 and you may return the same index twice. 2. Return indices, not values. The problem asks for positions in the array, not the numbers themselves. 3. Duplicates are fine, as long as the two indices are different. 3 with target 6 returns 0, 1. Both indices are distinct, even though both values are 3. The pattern: this is all pairs brute force. Check every combination. It shows up in 3sum, 4sum, and the brute force version of 2sum sorted. But here's the deal: almost every all pairs brute force can be cut down with hashing or sorting. The smart move at interview time is to write the brute force, say its complexity out loud, then immediately propose the optimization. Half of every iteration was wasted. We kept asking, is there another number that adds to target? But we already saw all the numbers before. What if we remembered them? That is the insight that turns n squared into n part 2 next, one-pass hashmap. Next time you reach for 2 nested loops, ask yourself, is there a hashmap version? Subscribe at CodeBrainery. And tell me in the comments, What is the worst O of n squared answer you have ever shipped to production? I'll feature the best confession in part 2.